Right, year nines. It's the last lesson before the half-term break, and before any other half-term break, I would be saying, right, we've relaxed, we've worked hard, let's do something a bit different. And that is true this time. I'm really impressed with how much work you're doing, really impressed with the questions you ask, really impressed by the work you submit online. Now, I know one or two of you got a little bit behind at times, but I'm getting the impression that you are all working hard. Think about it. Now, if you do think you got behind with submitting stuff, that's fine. Spend some time going through everything, and maybe if you think you haven't emailed me for a bit, email me tomorrow or during the next week and just tell me where you are with things. But honestly, so if it's, oh, I was great on this, but the challenging stuff was difficult, let me know that, because then I can start planning the next half term. Anyway, what do I want to do for the last Friday? Right, there are a lot of books in the world. Here is an idea of some books you might want to read before you die. All sorts of things, interesting things. But in that book, there aren't many books about our subject, which is maths, and there are a phenomenal number of good books about maths as well. Everything from This is Incredible, if you think you're interested in making money and economics and things, really well explained. There's a fantastic history of modern maths leading up to a fantastic piece of work by a British mathematician who came up with an answer to this problem. There's books that explain maths, all of maths, which is a fairly big subject. The one I want to come to is not that one by James Gleick, not that one, which are all good. I mean, a lot of them, though, perhaps you do need a bit of A-level to understand them. The one I want to come to is this one, which seems a good plan for any lesson, doesn't it? Which I've based a lot of mine on. So it's Chaos by James Gleick. And what I want to take you to is these fantastic images. Now, clearly, asking you to read all of that in a half-term break would be heavy going, bearing in mind you do need a bit of an approach from A-level. It's this bit I wanted to jump to. I wanted to jump to these fantastic diagrams in the middle, the thing like the Lorentz attractor, the Koch curve. Oh, in fact, I can zoom in a bit now, can't I? Because I'm only on a double page. Bzz, bzz, bzz. Right, and hopefully if I'm on autofocus, let's click the AF button. Autofocus on. Right. And we have these diagrams. So in a maths book, we have these fantastic diagrams on something called the Mandelbrot set. Should we zoom in on that so you can see that word? Mandelbrot set. A voyage through finer and finer scales shows the increasing complexity of the set, with its seahorse tails and island molecules representing the whole set. By the last frame, the level of magnification is about 1 million every direction. These diagrams here are all examples of Mandelbrot sets. I'll just zoom out again so we can see the next page. And that Mandelbrot sets are connected with this study of chaos theory. And at least one of you submitted me formulae to do with chaos theory last week. I would defy you, if you're interested in necessarily maths, but it's art or science, the wider world, not to be looking at those and thinking, wow, how is this connected to maths? Oh, here's some simulation of the Great Red Spot. So what I want to do this time is ask you to, and I'll jot down some words now. Now it all comes about this study. I'm just going to take you to, wonder if any of you recognise that, the what is it? The Menger sponge. That's something we looked at in class as well. The Koch snowflake. Notice that this chapter is called A Geometry of Nature. Okay? A Geometry of Nature. And yet relation appears a small relation expanding like the shade of a cloud on sand, a shape on the side of a hill. Wallace Stevens, Connoisseur of Chaos. Actually, I don't know what that means, so I'm going to go back to it. What I want you to look at, completely separate from the course, is spend some time. Go on to the what's it called, the Moodle, and by all means find the next quiz and submit the answers. I hope you're enjoying those. For the half-term break, I do want you to relax a bit. But I do appreciate some of you are thinking, well, what do you mean relax? We've been stuck in the house doing work enough. We've done enough relaxing. What about something interesting? What I'd like, before we get to the half-term break, I'd like you to look up the word chaos. By all means, look at the work of this author called James Gleick. You might find this linked to non-linear equations. You might remember at the beginning of, now can I draw a good diagram to represent this film? Tiny little arms. At the beginning of Jurassic Park, you are introduced to a mathematician called Ian Malcolm, aren't you? Treat yourself to the first bits of Jurassic Park where Ian Malcolm, the mathematician, talks about chaos theory, doesn't he? And he relates it to that film. If you're interested in maths, that will be enough. If you're interested in the art and things, spend some time looking at what the Mandelbrot sets are. Now, Menger's sponge, we looked at in lessons. We looked at the Koch curve. So you may want to treat yourself this time to fractals. And to inspire yourself, why not listen to the only song I know which quotes fractals is Let It Go, Let It Go, in the rain, the wind, the blah, 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 blah. Fractals. Have a look at how this might apply for, and what was the title in that book? The title of the chapter in that book was Geometry in Nature, wasn't it? Geometry of Nature. And you might find it linked to things like, I'm just going to pause it for a second. I'm going to get my other book. And if nature's your thing, but not necessarily maths, I'd invite you to think about this idea. So, tree guide. I've opened up to about oak trees. Let's zoom in on that again, only so I can play about with this machine. So, oaks, Quercus, Quercus robur, the English oak. So, some of you might know that an oak leaf is that shape, but I think you will find it nigh impossible to find that oak leaf. You know that oak leaves look like that, but you really know, if you think about it, all oak leaves are different. But all oak leaves are different, but all English oak leaves look like that, and all sessile oak leaves look like that. All Quercus pedunculiferlis. Oh, I'm only chuckling because I've seen the word Koch there as well. Look, Koch curve. I wonder if they're named after the same. Anyway, that's not what I wanted to do. All oak leaves look the same, but they're all different. If I turn a page, these are different oak leaves. Every one of the Turkey oak leaves is different, but Turkey oak leaves look like that. English oak leaves look like that. There's a similarity, but a difference. And as you flick through, this book can say that hazel leaves look like that, but you will never find that hazel leaf, will you? You can go out and you can find hazel leaves that look like that, have that sort of serration there, but they'll be different. Chaos theory, is also about the fact that the shape of that is defined by probabilities, by a set of non-linear equations. You could look into, and just watch videos on it, I don't mind, how we might have a set of equations defining something that always takes this general shape, which defines an oak, but all oak trees are different. Linked to things like the snowflakes, the geometry of nature. And that's the essence of the chaos theory. That from an initial set of conditions, we can't predict everything that happens. Other things you might want to look up. You'll soon see, I don't really mind what you do for this hour and for the week that follows, as a lot of it is going to be that. But that doesn't mean we can't be expanding your brains, don't I? Because I did say I wanted to come back breaking your brain. So I'm just going to write one more phrase down. I'm going to write down butterfly effect. Okay? Chaos theory. A lot of the maths we do is archaic. A lot of the maths we do, when we look at this number line from where we are now, the Middle Ages, back to the Arabic mathematicians and the Greek mathematicians, Pythagoras was way back here, wasn't he? The Arabic mathematicians giving us algebra were way back here. Newton's laws and Kepler were here. This work brings us to here. Right. 15 minutes of me getting to the point where saying that for a week. By all means do next quiz on Esmodo, and I'll keep checking the scores. If you don't enter one week, you're not going to do as well as the people who do. What a brilliant illustration of it. Chaos, whether it's Mandelbrot sets, Menger sponges, fractals, Jurassic Park and Ian Malcolm, butterfly effect, James Gleick reading that, the geometry of nature. Go out and find all the different hazel leaves you can and see what the differences are, etc, etc, etc. Then, when we come back, Mr. Mackenzie and I will keep trying to blend the revision of what we've done, so you're not missing out on what the other groups have done. Moving over the GCSE course, because that's what we're going to be examined on, and stretching your brains. In fact, go out. The other thing I want you to do is go out and buy a proper sized head belt so we don't split your heads next time. Right, I will, whatever form seeing you will take after the half-term break, I'll do that. Email me if you haven't done so for a couple of weeks, whether it's tomorrow or during the week. Email me if you have done. Right, 30 minutes 53. I'm going to stop at 14 minutes.